Does that make sense, Sagar?
Yeah. So we should discuss this. Like we should be asking this upfront in any problem where they talk about k, because then we have to match up to the what is the case value and what you gonna sort.
But one interesting point, right? See here, we have a stream range. Okay, okay. Stream range is only 10,000. The value stream range is only 10,000. That is the reason why the k is up to 10,000. Okay, the values could be minus 10,000 to 10,000.
Uh, so the reason I mentioned that is, let's say if your case value is just one,
Okay.
do you need sorting for that? Find the largest element.
See, in a stream, right? Let's take an example of okay this one. Okay, okay. So you saying this is my stream. Okay, you saying k equals to one, right?
Mhm.
Yes. In this case also, I need to do a sorting, right?
So what would be the complexity for sorting? Sorry.
So sorting is n log n. Any sorting. I mean, irrespective of the n is the total number of like in this case 4 log 4. So
But every time when you add an element to the list, right, then you need to sort it.
for every time we need to sort it. Yeah. For
Yeah.
every addition, every add, we need to sort it.
Um, we can try to add that. Can we, before even going there, Deva? Um,
Yeah.
if we, let's say, take a static snapshot of the current list, let's say 4582. Consider this is a current snapshot, and then now we have to find k equals to one.
If they guarantee that the given input is sorted, then we don't need to sort it.
Consider it's not sorted so far.
Okay.
Yeah, it is not sorted. It's a running streams. Um,
Yeah,
so in that is the case, right? It is it's a regular for identifying a max value in a list. That is this, right?
correct. So what would
So
be the best case scenario in this case?
so the best case, right? One thing is the sorting, and the other thing is um, I mean we can do um, like index hash table also we can maintain it or
No
Unless
need, right?
otherwise you don't linearly look up everything, right? You will not be able to find out what is the kth largest, right?
correct.
So
Why?
Correct.
definitely we
Why?
can achieve this by WAF here.
Shini, I have a suggestion over here. So let's say we are discussing about heap. So what if we keep a heap and we only keep the let's say k number of elements in a heap, and every time we need to we add and we check the heap size, and if the size is greater than k, we take out an element from a heap.
Yeah, yeah, yeah.
So
So
Yeah.
so in this way we can just take the top of the heap every time, and that will guarantee the kth largest element.
Yeah, yeah, yeah. You're right, but yeah,
because
we are at to discuss the heap solution. I think. Yeah, you're right.
Yeah,
Yeah, yeah. We will discuss it. Yeah, yeah.
yeah. So Ravi and Deva, like even before even Trini, even before we go about sorting, even before we go about heap, what is the simplest way to find out the largest element from 4582 is my question. Because let's say if it's a snapshot 4582, you can just run a for loop and search for what is the max value. Let's say for if four set the max value, you get 5 is greater than 4, so you change your value to 5. Then you go to 8 is greater than 5, you set it to 8. Then 2 is not greater than 8, so you keep it 8, and then you reach to the end. So it's a linear, right?
Yeah.
So you don't even need to do sorting, you don't even need to consider any other thing. Basic thing, when case value equals to 1, it should be a linear, because you just need to, from an array, you just need to find what is the max value. Now let's say if case value is 2, Okay, that's one thing that can change is now k value is one variable and length of your array is another variable. So let's not worry about the length of the array. Let's just worry about k at this moment. Let's say there you want to find k equals to 2. That means top 2 max element. Now how your solution changes? Let's say you keep max 1 and another as max 2. Okay, so keep your max 1 to max, which is 4. Can you write for the array there, Ashwini? 4582. Yeah, you have max 1 and max 2 here. First, set it to 0, both, or maybe negative infinity.
What?
Max, yeah, set it to negative infinity. Let's say for time being, set it to 0 as a minimum value,
Okay.
and both are 0. Let's say you come to 4. 4 is 4 greater than your max primary? Yes, set it to max primary. Then come to 5. Is 5 greater than your max primary? Yes. Then set the max primary value to 4. Max secondary value to 4. Swap it. Yeah. And then set the primary to 5. Then come to 8. So 8 is greater than 5. So swap the values. Make it 5 and 8. Yeah. Now come to 2. 2 is not greater than any of these. That's it. You stop. So that's how you have your max value and second max value. So these are two largest values. What if you have three largest values? What if you have four largest values? So the
Quick
simplest
question.
solution that should come that comes to my mind is not sorting everything. It's just running over, because this is a linear search. So it's important to ask for the case value, and there could be a possibility that going into detail of anything. Let's say your length of your array is 10 to the power 5, 10 to the power 10, and case value is just 5, 5 constant, or just 10 constant. So the first thing we should ask is, if k is minuscule as compared to the length of array, then let's do a linear search and keep swapping it in between, so that it will be effectively less than even sorting. The moment when your case value keeps increasing linearly, that's when your swapping part would become costlier. So that would be O of k into O of n every time, possibly. So that is n value of k into O of n. That's the first solution. Complexity should be O of k into O of n. If k is very very small, then your overall complexity converts into linear search.
Uh, so, for every k, we'll have to compare the value, right? So when two, let's say we are processing two in the array, in that stream, uh, so we'll compare it with max primary, max secondary, and let's say if there's k equal to 3, so the third value, fourth value, right?
Correct.
Okay.
Yeah. That's yeah. Brute force one.
Yeah.
So just to understand the basic concepts, basic knowledge. Yeah.
Yeah.
See,
And
I even
there is a
forgot
reason that
explaining this.
I'm covering
Good
this
point.
approach. There is a reason. So right now, let's say we discuss that k's value has increased linearly. This so far this was so condition for this line 42 is k is lesser than n.
Yeah.
Now
Um,
there are two
so
possibilities.
any questions before we move on to another approach or another one? Anybody has any questions or anything that needs to be clarified?
Feel free to
No,
people
Shri.
feel free to ask as many questions.
Yeah. Please, because that is where we will learn. We all will learn. Okay. Yeah.
Or feel free to find mistakes in
Or any alternatives also,
yeah.
because we know, I mean, we know the algorithm heap is the best one, but if the same way if we discuss, right, that will be applicable in some other way. That's why if you guys feel anything is any other solutions, just speak it out. Yeah, yeah, go ahead, Sagar.
Yeah. So now there are two deviations from two follow-ups from here. What if k's value increases? So now, and on line 42, can you write the condition that k is lesser than n?
What k is less than n? Okay. Yeah, these under boundary cases you're talking about, right?
Yeah, yeah. So this is like this is under the assumption. Basically, it's not no, not even boundary case. This is just assumption that we are assuming for sure that k will be very lesser than n. So whenever k's value is
All
very
right. I mean, that's the input they're given, right? I mean, so in the constraints itself, they're given that
yeah, yeah.
k will never.
Yeah, yeah, but the interviewer might not be asking it in general. It could be a general terms question, right? So the reason is like there could be cases where we need to find the max elements or mean elements, but then we might not need anything sorting or whatever. So the
Okay.
reason we need sorting is because k's value is so greater, is so high that we don't want to keep shuffling those values in between. So if k increases with the in order of length, then we need a sorting. So if we sort it, then we don't need to shuffle in between linearly. It will be just O of one value. So how that would be, then basically we will sort the 4582 array, maybe on line 51 if you can sort that array.
So the one thing, Sagar, this is a stream of events, right? Stream, that's a data stream, right? So the k will never change, right? I mean, that is our business use case, right? That is a primary case, whatever it is, right? So the stream of events changes, right? That varies. It could be one, it could be two, it could be 10k, it could be 5k, right? Based on the based on that delta, right? How much stream, how much data we are getting it, right?
Yeah, yeah, Srini. Yeah, I'm coming to that as well.
Okay, so you are saying 51. You want me to write something?
Yeah, just sort it.
Oh,
And
sort.
then sorting, when we sort it, then if we find the k, then it would be just O of one thing, right?
Um, Sorting in which one? Ascending, descending.
Ascending.
Ascending to 4, 5,
Two,
8. Okay.
four, 5, 8. Yeah. So here, if you sort it, then it would cost you n log n, that there itself. And then on line 54, maybe, yeah, yeah. Then on the next line, you will find the length minus k index.
Yeah, length of n minus k, right? So yeah,
Yeah,
so that is our the return value, right?
that would be your kth largest value. So the
Yeah,
catch here is that you sort it for the current snapshot of array.
correct.
So now your k could be any value and you will still be able to find it in O of 1. But your linear search, basically O of n converted to O of n log n. And now another follow up would come in that now the linear snapshot that you took 4582, what if the array itself changes? So if the array changes, let's say earlier the array was 4582, now the array become 4582 110. Can you write that array? 458.
No, you're saying the next stream, right? You're
Yeah,
saying,
yeah. So let's say, yeah,
right? Another stream. I mean, this is done, so we're getting a next batch of different values, right? You're
yeah.
saying, right?
Or
Okay.
just extend both. You can get a different values, or you can extend the current array. You can extend the
You
current
can't.
values.
No. I mean, in the stream of events, right, it cannot be overwritten the once it is received, right? So we have to get the next stream only. It will not be appended into this.
Why? You're just
No,
collecting the
this is not
collecting it
exactly
into
right
some
because
bucket, right?
no, I'm talking about this exam, this problem, right? So when we issued an edition, right? Add an API, let's take add API. That means, right, we have some time delta of numbers of the stream, so we'll be adding it, right? And next, after again 1 minute, we'll issue on one more API for addition of next one, right?
Yeah, that should still be fine, right? So basically your add will keep appending to the to your array. Let's say you are maintaining an array data structure.
Yeah, I got, but I got the problem. I got it. So that's again the problem statement will be different. That's what I'm saying that for that. But in this case, we are not depending, right, to the existing ones, are we?
Yeah. Why,
Yeah, we
why
are appending.
I mean, like,
Okay.
why, what would be a problem with appending is my question.
Yeah, there is no problem. Yeah. Yeah.
Because we need to include the newly added number to find the kth largest again, right?
Correct. 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 Yeah. 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 I got it. Yeah. Okay. Okay. Sagar, go ahead. Yeah.
Yeah,
I'm
so
maybe.
now you had a sorted copy 2458, right, on line 52. So add the next values to itself. Add the next values to the sorted copy itself. Remove the line 58 array.
Okay. Meant to say. Okay.
Yeah, since it is already in sorted state. On that
Okay.
sorted state itself, add 10 and 1 maybe.
Okay.
Yeah. So in 10 comma 1 maybe extra. Yeah. So now the moment you add 10, so there are two things possible here. Either you add it as it is, so your add time complexity will be O of 1, and then whenever you will be calculating your top k value, then you sort it. So basically your add operation could be O of 1, and your calculating top k value could be O of n log n. Okay, but there is alternative to that. Whenever you are adding 10, let's say if you find out what's the right place for adding that value. Let's say you come up with some other structure, and why during the add time itself, if you're able to properly place 10 and 1 to its correct place. So let's say on one side you added 2, 4, 5, 8, 10 and 1. That's one way. And on the side of that, on line 58, yeah, you keep,
Yeah.
yeah, they on the same line. Yeah, put
Okay.
1 in the beginning, and then 10. Yeah, remove on line 59. Yeah, so there are two ways to add. In the first case, you just add an O of 1, directly append it. And in second case, you rightly place 1 it's to its basically a sequential order or ascending order. You place 1 in its correct order. So there, let's consider there is some complexity involved in adding that 1. So in this case, in second case, calculating the top k value will be reduced. Basically, in first case, calculating the adding the can you on line 59, can you write add and calculate top k largest? In the first case, add, and then below that, it could be k largest. So add complexity in first case is O of 1, and k largest is n log n. Okay, and in second case, add complexity would be greater than O of n, but kth largest would be linear or less than O of n. Linear as in n or less than n, O of n.
No, I mean, I didn't quite get this point actually.
Yeah.
So add should be of n.
So let's say it's still an array on line 58. The second value, it's still an array. 1, 2, 4,
Okay.
5, 8, 10. The second value. Call it b. Yeah, that B is still an array, and you have to find third largest value. How would you find it? Just O of one, right?
But addition is not O of n, right? That's what I'm
Yeah,
saying.
addition is not O of one.
Yeah. So addition should be O of one times, right?
Yeah,
And larger. I mean, this is a proportion, right?
yeah,
If addition is more and kth largest will be, you can find it one of O of one. In
yeah.
this case, addition is O of one, right? If you say
Uh, in second case, addition will be O of n.
n, okay,
Yeah.
okay,
Consider
and
you might
then
need to shuffle all the elements.
okay, okay. So you wanted to add it in this way, right?
Yeah. If
When a ten comes, right, it has to go to the end of the list, and
yeah,
when one comes, it has to come to the at
yeah,
the front of the list, right? So
yeah,
then definitely it's O of n. I mean n in the sense the previous into O of n into m actually, right? Where m is the newly added element and where n is the already existing array.
correct, correct. So now the reason to break this down into these two cases is, first one is, let's say your read operations are great are of the order of 10 to the power 3, but you're doing write operation only once. So that means it's okay to take the add complexity higher and your read complexity lower. But there could be a
Yeah,
case where it's a stream, as you mentioned earlier, and let's say you're making 1,000 add operation and just one read operation. So if you're
correct.
making 1,000 add operations, that means your add has to be faster,
Yeah,
but your read could be slower. So that's what the line 59 and 60 talks about. Your write is faster and your read is slower. Second one is your write is slower but your read is faster.
makes sense. Makes sense. Yeah,
So when we are trying to maintain something like when we are trying to maintain something like a sorted value or sorted array, when we are trying to maintain the array in always a sorted manner, that's where we need heap. So why do we are going to heap is, if you read the fifth constraint, uh, fifth constraint, yeah, at most 10 to the power 4 calls will be made to add. So that's where basically there could be all sorts of follow-ups coming in here. So how many read calls are being made, how many write calls are being made? To justify that, we would want to keep the array all in always sorted manner, because we need to add as well as keep reading it. Does it make sense?
I mean to say here, right? So 10 power 4 add. That means right, 10 power 4 returns, right? That means 10 power 4 reads too, right?
Yeah,
Not reads, right? It has to return every time. But that means like 10 power 4 reads, right?
yeah.
Okay.
So now, what happens in
Okay.
case of heap?
Sagar,
Hold on,
why
hold
it
on.
is power 4?
Anybody has any questions? Let's ask questions. Yeah.
Yeah, I have a question. Is it said at most 10 to the power 4 calls? What is that? Can someone explain? What is that?
I think it's based on constraint, right?
Oh,
So the limit is right. So 0 to 10 power 4 is a number length, and uh, at 10 power 4 calls will be, this is what, right? So their condition, their input variation is like it will be called for 10 power 4 times, right? This can go up to 10 power 4, these additions. Does it make sense, Aditya?
yeah, yeah, yeah. So basically, you were referring to the constraints, right? I think, right?
Yeah.
Mm-hmm. Okay, sure.
Yeah, go ahead, Sagar. I have to leave in maybe like 5 to 10 minutes.
Yeah.
So
So yeah, I am
yeah,
almost done. So this is the point I wanted to make, is what why we need heap is, heap will always try to maintain the array in line 63 format. But the cost of using heap is, every time your add operation comes in, it will take O of log n times to add any value. So the reason we need heap is to always maintain the stream in an ascending or a descending manner. Okay, and to maintain the stream in ascending and descending order, every time you add any element, it will take O of log n complexity to keep adding it. And what would be the complexity to read the kth largest element is that would be a question I would want to ask you guys.
It is O of k, right? Um, kth largest, right? That means
Is it?
third largest. I mean third largest, right? Um,
Consider case
so
value
it's
is
O of
100 or
one actually.
1000.
O of
Was that?
Consider
O of
case value is 100 or 1000 more than basically 10 to the power 2 or 3.
But anything, right? I'll have to maintain my top of the queue should be my largest value. That's why I have to construct my queue.
which is n log n.
Yeah, that's the question.
When we are doing addition log n, right? Addition should be n log n in that case, right?
It should be n log k because you're trying to maintain the heap of size k, right?
Don't worry about size of heap or whatever. Just worry about
So,
how will you
so,
find the kth largest value.
so here two parts here. Earlier, right? Two parts. One is when we are adding, right? When we are adding an element to a queue, right? So after adding, it has to reshuffle it, right?
Correct.
So the reshuffling in such a way that my largest value should be top of the queue. So if I make it that way, right, I can get it. I mean, my set square should be O of one, right? In that case,
Correct. So if you are trying to read the top of the queue, then it would be O of 1. But
correct.
after you remove the top of the queue, you will need to maintain the order as well. So you need to bubble the 8 value to the top again and then reorder the rest of the array. Okay. That reordering will take log n operations. So to popping out, it will be just if you just want to read it, reading is O of 1. But let's say now your case you're not interested in top k value, basically top of the queue. You want second top or third top or fourth top. In that case, you will remove the top, you will reorganize it, again remove the
But
top, reorganize it, remove the top,
but
reorganize it. That will give you top third value. That ordering will take log n times. So let's say if you have kth largest, then it would be k into log n. That gives you the k log n.
so once I see this, I mean again, my understanding here is right. So the reordering, right? Reordering. Okay. So you mean to say the queue, like the largest value will be there in the top of the queue. A rest can be in any order. You're saying
That you don't need to worry, right? That's the internal implementation of heap.
that is why we need a reordering, right? Here,
Yeah.
why do you need a reordering then?
So reordering is when you need second top value. If it's a top of the value, top of the queue value, you will just read it. Okay.
Yeah, I did it right. So in this
But
case,
you
right,
won't you don't have in heap, you don't have access to the second element or third element inside it.
I will pop it, right?
Yeah.
So
So
you can pop.
popping operation, reordering will be involved.
Okay, you mean to say pop? Okay,
Yeah. The moment you pop, reordering will take place.
okay, okay, okay.
So if you want to find the
So
kth largest, then you have to pop it k times.
No, actually, that is what, right? I mean, you may not need a k times, right? How you arrange what kind of heap you're using, right? Because if I need a k is at the third largest, right? I don't need to pop three times, right?
So in heap, you don't have access to the internal elements. You only have access to the top.
Correct. But whether you use a max heap or min heap, based on that you can identify, right?
Consider that you are arranging it in a descending order. Your top of heap will always be the max value. Consider this as a max heap so far.
So in this case, right, 10, in this example, right? Let's take this example only,
Uh-huh.
right? So my top is at 10, right?
Yeah,
And then I'm assuming it will arrange in such a way that something like this, right?
in descending order.
Um,
Consider it descending order.
uh, right, 2 and 1, right?
Yeah.
So when I pop it out, right? If I don't add anything in the queue, right? Then this is my the first element in the queue, right? So
No, the moment you pop, it automatically organizes it, it reorders itself because it wants to maintain the structure. So it doesn't know whether 8 is connected as a left child or right child, or 5 is connected as a left child or right child. It doesn't know it. It reorganizes. Basically, it does the heapify operation, right? Heap order maintenance. Every single pop operation, it maintains the heap order maintenance. So when they talk about the complexity of pop operation, they never say O of 1. They always say O of n, O of log n. So log n would be the
okay,
reordering complexity.
okay.
I can share the heap how they maintain the heap order video. I have a good video on that. I think I did share it, the take dose video on the other day in the channel. I can share it after the session, Shrini, or for anyone if you are looking for how they maintain the heap order, how the popping and what is the complexity of popping.
Sure, sure.
Yeah. So now if you pop k times to find the kth largest, because you are not interested in first largest, second largest, third largest, you are interested in the kth largest value. So you have to pop k times. So it would be k log n.
Okay.
So that was the case when you are using the max heap. Now another question for everyone is, can we do better than this? So
Sagar, I'll give control to you. Can you, because I have to leave.
sure, sure.
Yeah, you can discuss. I'm just posting. I don't know how to share this one. There should be some option.
Just paste it in chat.
Okay, WhatsApp.
Jitsi chat. Jitsi chat.
Okay, yeah, I pasted in WhatsApp. Oh, Jitsi, yeah, okay. Okay, I pasted.
Thanks. Yeah. Yeah. So shall we continue here or stop? I'm not sure. Like if we are already about time, so if folks want to stop or continue, just let me know. I'm open for anything.
Or let's continue, Sagar.
Can
Uh,
we do tomorrow?
Sorry.
Tomorrow? Let's continue tomorrow.
Okay. So I have one vote. Anyone else? Okay. I think let's. So just only question that I wanted to share here is like, can we do better than k log n? So we are getting k log n when we are getting a max heap. We are using a max heap, and the reason we are getting k log n is to find kth largest. We have to pop k times. So if we still want to increase it further, can we do better? So that's the question I would want to ask, and we can come back to discuss this question tomorrow.
A quick question, Sagar. Max heap means the maximum will be on the top, right?
Yes.
So kth largest means, do we need to put a min heap so that uh, let's say the fourth largest or kth largest, right? That will be on the top, which is the minimum one, and we can pop that.
How would you do that in this case? You don't want to lose any of the element from 4 to 10. So let's say 1 comes, what would you do? You put it into heap, right?
Uh-huh. So
Can
I
you?
create a heap. I mean, this is just a regular solution, right? We create a min heap. So it is putting the elements in an ascending order. The minimum is on the top, right? But the min heap, I would keep always only four. As Ravi he was mentioning, like we would keep like k elements, I will keep it only k elements, but it would be a min heap so that the minimum would be on the top. So in this case, right? So let's take 1, 2, 4, 5, 8, or maybe we can take this sample 4, 5, 8, 2, bro. So it is going to be like 2, 4, 5, 8, right?
Okay, so let's say we have something like this.
Yeah. So right now, as planned, 4 is on the top, which is the minimum. So when I peak it or when I pop it, fourth will go out. That is the fourth largest right now. So let's assume that now we have one is adding, one is getting added, right? So when I have the first instruction, or let's take the, yeah, I mean, we can add one right now. If there is an add command comes in, so now we would add one. So my understanding is what now the heapify process fire in, and then it would put one on the top and then 4, 5, 8. Then what we would do, since we are going to keep only four elements or kth elements in the heap, we would delete the 10.
Correct. So
Yeah.
you don't even need to delete the 10. You need top k elements, right? So
Yes.
when we say top k elements, uh, your k size, kth element basically. So to read kth element in O of 1, or just peek it,
Uh-huh.
your heap size has to be
O of k.
like length k. Yeah,
Length k.
O of a. Yeah. Okay. So the difference between earlier than this one is, earlier the elements were arranged in this fashion: 10, 8, 5. Let me draw it this way. It was 10, 8, 5, 4, 1, 2, and 1. Okay.
Mhm.
Earlier it was arranged in this way, and here we are trying to find top fourth element. So what we were trying to do essentially is this the top fourth? No, this is top first. So we are going here. To go here, it takes us O of log n. Okay. If this is it, no, we go here O of log n, and then this is our top cave of basically top fourth element. So that's where we stop. So that becomes 4. But what, according to what you mentioned, we are arranging it in this way.
Uh-huh. So
So,
here you are using the max heap approach, right? So you mentioned the line number 59 to 64, right? That's a max heap approach. So you are saying we would load, let's say, take the first example, 4582, right? So it is going to keep 8542, right?
uh-huh.
So then if we need the fourth largest, we need to pop four times, right? So
Yes,
you are saying like pop it four times, or maybe yeah, four time pop it, and then whatever the value, just to bring it in. But
correct.
we may, or you mean to say peak it, right? I mean that's what you are saying. Like, oh no, no, we may not be able to peak it, right? You can peak only the top
Yeah,
only.
yeah, yeah. So here, if you arrange it in reverse way, you just maintain the heap size of length k, and it will your heap will have only k elements, starting with starting with kth largest
Yeah,
to largest in ascending order. Does it make sense?
yeah.
That's the
So
difference between this one and that one.
okay. So this can be, I mean, this problem can be solved using both the heaps, right? You are saying like we
Correct,
can solve this through min heap as well as max heap too,
correct,
but it depends on how we are approaching the problem.
correct, correct.
Okay.
Now you need to pop 10, or let's say you need to pop any of the element, but you don't want to lose the data. What you will do? So let's say right now you are calculating kth value as top fourth. Then you want to find the top second value, but you don't. So let's say you come up with mean heap, which has 4, 5, 8, 10. Okay,
Mhm.
and now you are not interested in top of fourth value. Now you are interested in top second value. So far, what will you do? So consider before this you also have 2 and also have 1, which are not currently part of this one. uh, but those you did get these elements earlier. So there could be two scenarios. They might ask you to calculate top second value, or they might ask you to calculate top fifth value. So in this case you only have fourth value, there is no scope of fifth value.
Mhm.
Any questions so far? Any?
Sagar, I didn't understood the last part. Like, is it like an add-on, like finding the top second and top fifth?
Yeah, this is a follow up. Let's say earlier
Mm-hmm.
we were just asking for top fourth element. That's it, nothing else. The problem was just trying to call only the kth largest once. Okay,
Mm-hmm.
but let's say now k's value is changing. So first they ask you to calculate the top fourth, then they ask you to calculate second top, or they can ask you to calculate the fifth top. What will you do? Because
Oh,
your heap
okay.
just have four values, your heap
Uh-huh.
your heap can't have two values or like that, otherwise you will lose data. How can you do this without losing the data?
Okay, now I get the problem. You are saying here the problem here the ask is constant, right? Which
Yeah,
is the kth is the constant. So you are making the kth as dynamic, right? So what if we have a multiple k
yeah,
keep on coming and asking that?
yeah.
Okay.
So to anyone has any answer to this, or even Deva?
Definitely, I'm thinking that then my understanding is because the k can be 1 or the k could be 10 to the power 4 too, right? So I think my understanding is definitely we have to keep the heap in a way that it should hold everything.
But isn't your max heap holding everything?
Yeah, yeah. So definitely here, like, in the min heap approach, we said, like, let's keep what is the k, but the here, since the k is constant, so we decided let's keep only the heap as k size. But here the k is going to be very dynamic. I think we have to keep all the element, either the min heap approach or the max heap approach, right? We have to keep all the element in the heap, but somehow when there's a ask comes in for a particular dynamic k, at that time we need to figure it out how we could go and take it and then return it.
Yeah. So can you combine both of these two? The first one is able to keep all elements, the second one is able to maintain the kth value. So the answer for this could be you maintain both max heap and min heap. Okay. So let's say you maintain a max heap for element lesser than fourth value, basically less than 4, whatever elements that you get, less than the peak or less than the top of heap, you add it to a max heap. So how it would look like is 2 and then 1, this would be your max heap, and at the same time side by side this you maintain a mean heap, which would be tracking your elements greater than 2, so which would be 4, 5, 8 and 10. So this is your max heap and this is your mean heap. So let's say now you have to calculate, uh, let's say calculate kth largest. In this case, make the heap size, make the mean heap size equals to k and read the top value. So let's say if k equals to fourth largest, then you read it directly. If k equals to fifth largest, what you will do is you will pop one value from here and you will push that one value here. So your size of your mean heap becomes 5 and the top of this heap is your fifth largest value. So essentially what we are trying to come up is a wedge like structure. So basically this and like this over here. So this is your max heap and this is your mean heap. Now we can keep playing with k. So if k is, let's say, the total length is equals to, let's say, 10, and let's say if we ask for k equals to 5, let's say k equals to 2, then this value, then your mean heap value equals to 2, like length of your mean heap equals to 2 and length of your max heap equals to 8. Let's say now you want k equals to 5, then length of mean heap equals to 5, length of max heap equals to 5. This is nothing but your median, because it lies in the middle. One side you have 5 values, one side you have 5 values. So this is nothing but your uh, top of mean heap is nothing but your 80th percentile value from stream, and this is nothing but your 50 percentile value from stream. Now by adjusting the length of mean heap and max heap, you can change percentile, top kth percentile value. Does this make sense?
Yeah, makes sense.
Yeah, I think we are already about time, like over time in fact. Shall we stop here and come back to this discussion tomorrow?
Yeah,
I have this recorded. I can also upload this. Asim did share with me the YouTube channel, so I would be uploading this. If you guys want to look at it. You can basically refer it. Right?
Yeah, sure, sir. Yeah.